For the past 2 years, I've immersed myself in the world of DIY hydrofoil construction. The joy of shaping my own gliders has opened up a thrilling new dimension of flight with each design. Every iteration brought improvements, but with my latest gliders, I've hit a frustrating speed limit. No matter how small I make them, I struggle to go beyond 25 knots without big wipeouts. A big contributor to this is my mast. My current version 3 mast is 15mm thick, much thicker than the 12mm masts used in Formula Kite racing. That extra thickness adds significant drag. To break through this performance barrier, I decided to build my own version 4 mast. The goal is to make it thinner while maintaining at least the same stiffness as my V3. It's not an easy project. A thinner mast means less potential stiffness and less room for inserts and bolt connections. But with the right workflow and basic tools, it's possible. I've had many failed attempts trying to get this V4 mast just right, but in this video, I'll show you what finally worked for me. I'll explain how I built the mold, what goes inside, and how to make the base plate and bolt connections for the glider. I believe this new DIY mast will unlock new levels of performance and speed for my future gliders. And I hope this video can help people trying to achieve similar projects. There are 2 main ways to make a hydrofoil mast. Method 1 is to shape a core from a rigid material like wood, then laminate it with fiberglass or carbon. This works well for thicker masts, but it involves a lot of sanding and makes getting a perfectly straight, symmetrical shape very difficult. Method 2 is to use a mold. This allows for several techniques like expanding foam cores, bladder molding for hollow masts, or compressed full carbon core, which is the method I'll be using. The key is applying pressure inside the mold to push the carbon fibers against the mold walls to get good stiffness. The first step was building the epoxy mold. I started by building a mold container using some 2x6 and 1x2 boards I had on hand. The 1x2s formed the side walls, slightly taller than the mast's thickness, and the 2x6 piece served as the lid, and the mast fit snugly inside. The challenge was finding a hydrofoil mast to mold from. Thankfully, a friend lent me his race mast. Next, I taped the ends to prevent epoxy from spilling out while allowing the mast to fit in. I applied Crisco butter to the mast to help the plastic wrap stick and to act as a release agent in case the epoxy got on the mast. The plastic wrap is crucial. It will later separate the top and bottom mold halves. I used a spatula to press out any air bubbles and tuck the wrap under the mast. Then I mixed a high-density filler with epoxy to make a liquid paste. I made it slightly too thick by accident, but I spread it out evenly and pressed the mast into the epoxy, making sure the epoxy filled up the leading and trailing edges. I pulled the plastic wrap up over the mold walls to keep the mast's edges straight and contain the epoxy under it. Then added a top layer of plastic wrap, removed any air bubbles, and taped the ends again to prepare for the second epoxy pour. I filled the mold until the epoxy covered the mast completely. The camera froze here, but the next step was placing the second 2x4 on top, which bonded to the epoxy. Once the epoxy cured, I used a grinder to clean up the edges and added 4 alignment markers to help line up the mold halves during closing. The mold opened easily. The top half looked great, but the bottom had 2 small air bubbles. That happened because my first epoxy mix wasn't liquid enough to let the air escape. I fixed this by filling the bubbles with more epoxy and sanded it smooth. I added door hinges to one side for precise alignment during molding, then coated both mold halves with Crisco butter and plastic wrap to prevent sticking. The mold was ready. To make this mast, I used two types of carbon tape, unidirectional and biaxial. The goal was to prevent bending and twisting. To prevent bending, fibers need to run in line with the length of the mast. To prevent twisting, fibers should run diagonally. I couldn't find carbon tape with plus or minus 45-degree angles, but I discovered that pulling the top and bottom edges of the biaxial tape in opposite directions angled the lateral fibers to about 40 degrees. Placing this into the mold would contribute to both longitudinal and torsional stiffness. It wasn't a perfect 45 degrees, but it simplified the lamination process. Once I had all the tape cut to the right length, I began layering. The unidirectional tape went on first to clearly define the edges, then I added the biaxial tape, pulling it tight to increase the diagonal angle. Each layer was mirrored on both mold halves for symmetry. Since the mold is tapered from 15mm to 12mm, I added extra layers of carbon to the thicker side to compensate. I kept adding layers until each mold half was slightly more than full. I used a straight edge to check this. It should slightly sink into the excess carbon. With the lamination done, I closed the mold. The hinges helped keep the top half aligned, and because of the excess material, it didn't close all the way at first. So I used bar clamps to compress the fibers and squeeze the epoxy out of the sides. The little markers told me when it was fully closed. The next day, I opened the mold. Thanks to the plastic wrap, it opened easily. The result was a beautifully shaped carbon mast with compressed carbon layers. I trimmed the ends to reveal a clean profile and dense carbon all the way through. The most critical part of the project was complete, but there was still a lot more to do: the base plate and the bolt connections. For the base plate, I made a simple mold. I traced the outline of a base plate onto a 6x1 board, cut it out with a jigsaw, and screwed another 1x6 underneath. Then I applied Crisco butter and plastic wrap to both mold sides. That's it, the mold was ready. I added layers into the mold, starting with carbon, then some fiberglass for extra thickness, then more carbon. I closed the mold and clamped it down as tightly as possible. Once cured, I cleaned it up with a grinder and drilled the 8mm holes for the M8 bolts. I marked the center line on the plate and outlined where the mast would sit. I glued the base plate and mast together using epoxy. The key here was getting the mast perfectly aligned and perpendicular. I used a 90-degree reference on my workbench, then taped everything in place. Then I made a fillet joint with high-density filler and epoxy. This acts like a weld and creates a very strong connection. After curing, I sanded everything smooth and scratched the mast surface to create a strong mechanical bond. I covered the bolts with Crisco butter and made sure everything was prepped for final lamination. I applied a 45-degree biaxial carbon layer, followed by 3 layers of unidirectional tape. I spread the fibers apart to insert the bolts and filled the base with epoxy until flush. secured, I had perfect indentations for the bolt heads. I shaped the base plate with a grinder and sanded it by hand until the transition looked seamless. A solid connection between mast and glider is critical for performance. While a small total box with barrel nuts and M6 screws is common, it complicates glider construction. I prefer wrapping carbon directly over the mast without needing to line up perfectly with the tuttle's top ridge. So I decided to embed barrel nuts directly into the mast. I found the mast's center line, marked the position for the nuts, and drilled holes, starting with small bits and working up for precision. I aligned the nuts with the M6 bolt holes and confirmed the bolts threaded correctly. Since the barrel nuts stuck out from the mast, I marked them and sanded them down until they were slightly thinner than the mast. Once they fit, I keyed their surface for a strong mechanical bond, coated the holes with epoxy, and inserted the nuts one final time. I tightened the bolts to have everything under load while the epoxy cured. To finish, I checked the leading and trailing edges to make sure they were straight. I tapered the mast's tip slightly to create a tunnel-like effect, starting just above the barrel nuts. The plan is that the fuselage will fit right on top of this taper, ensuring a tight connection. I sanded any remaining imperfections until the mast was smooth. Next, I taped one side and applied a hot coat of epoxy. It self-leveled into a smooth layer. Once cured, I repeated the process on the other side. The result looked great, except for some epoxy buildup on the trailing edge from surface tension. I wet sanded the trailing edge with 320 grit to remove imperfections and key the surface for paint. After cleaning and drying the mast, I spray painted it matte black. I finished by wet sanding with 800 grit to give it a clean, smooth finish. I added racing stripes just for fun and also sanded that to 800 grit. That's it, the mast is finished. It measures 15 millimeters at the top and tapers down to 12.6 millimeters at the bottom. Before I can test it out, I'll need to build a glider for it, so stay tuned for the next tutorials and the upcoming test sessions. Thanks for watching.